we are going to see the Polariscope, reflecting Polariscope, is also called Biot'S Polariscope. See what is this Polariscope and how it works and what is the work of it. To understand the Polariscope principle, focus on here the diagram. Let us consider here in diagram we have a rectangular glass of this shape. Let it is represented by P1. Its back side, this side is blackened by black color here. Right? Here in this blackened, see very carefully what is done. We are going to take a ray of light at a certain angle of incidence. When it is fall here, make a normal. The angle of incidence we are taking a polarizing angle IP. We are knowing this IP polarizing angle is for 57 degree for air glass. This incident light is unpolarized light. See the symbol here. Unpolarized light is fall here on it at angle of polarizing angle. Now what happened after refraction? This light is refracted. Reflected, not refracted. Phenomena of transmission will not take place because it is blackened from back side. Let us see. This is represented here by the black color. This color is blackened. This portion. And let it is P1 glass. This is a Polariscope. Here according to it, this unpolarized light becomes completely polarized here. Their plane of vibration lies perpendicular to the plane of paper. This is the polarized angle. Give the name here. This is ray number 1 and it is the ray number 2, which is polarized. This polarized light is called PPL, plane polarized light. Again, this polarized ray of light is allowed to fall in another glass block P2 here. This glass block is also blackened, coated with black color here in it. When it is fall, it's maintained in such a way that again it's make angle of incidence equal to polarizing angle, that is the 57 degree for air glass surface. In that condition, the reflected ray moves in this direction. Let us consider it is represented by third ray. This third ray is also polarized light. Their plane of vibration is perpendicular to the plane of paper. When intensity of ray 2 and ray 3 is obtained, then it found equal intensity. Here intensity of light number unpolarized light 1 is maximum, but 2 and 3 has the same. In that condition, the P1 is known as polarizer, where P2 is called analyzer. So P2 behaves as an analyzer and P1 behaves as a polarizer. And this whole device is known as Biot'S Polariscope or reflecting Polariscope. But see the situation in the second diagram here. The same rectangular glass block P1 is here, which is blackened at the back side here, right? And let unpolarized light is allowed to fall. Let me make the diagram for unpolarized light here. This is symbol representing unpolarized light. Students, very carefully draw the normal here. Now see reflected light. Here, this reflected light, this is light number 1, light number 2 becomes completely PPL, plane polarized, according to the first diagram, PPL. Right? Now what is required? Please rotate the analyzer here, like this. When it starts rotating this P2, here, a situation obtained where is no light, reflected light. The intensity becomes 0 in this direction. Compare with the former diagram, first diagram. Here intensity 2 and 3 is the same. But here there is no 3 light, no light. So this is called analyzer. This is called polarizer. And it is for testing that light is polarized or not. So that it is called analyzer. Since analyzer confirms that the light is PPL, plane polarized light. So to test these devices is known as Biot'S Polariscope or reflecting Polariscope. So this is for the topic. Thank you and have a nice day to all.